By the end of this lesson, you should be able to define kinetic energy and state that Ek equals half mv squared. Define gravitational potential energy and state that Ep equals mgh. State the principle of conservation of energy. Solve problems involving energy. A roller coaster does not have an engine. How does it work? The roller coaster works on the principle of conservation of energy. It possesses potential energy at its highest position, and it is transformed into kinetic energy as it comes down. Let's get to know more about the roller coaster action by looking into its kinetic energy and potential energy. An object possesses energy when it's doing work. Thus, the energy is said to be kinetic. The train is in motion and it possesses kinetic energy. The train moves because the engine pulls it. Work done by the engine is converted to the kinetic energy of the train. Let's consider another example, where a golfer is hitting the ball. When work is done by the golfer, that is, when the golfer hits the ball, it possesses kinetic energy. The kinetic energy of a moving object depends on two variables: mass of the object, speed of the object. Let's consider a trolley of mass, m, moving at speed v through a distance s. We know that work done on the trolley is force times distance. Substituting force in the expression of work done, work is equal to mass times acceleration at distance s. Since the trolley was initially at rest, the initial velocity is 0 meter per second. The final velocity after the trolley is displaced by s meter is v meter per second. From the equation of linear motion, substituting u equals 0, we get s equals v squared over 2a. Substitute s equals v squared over 2a in the expression for the work done, we get w equals to half mv squared. So, the kinetic energy of an object of mass m moving with a velocity of v is half mv squared. The SI unit is kilogram meter squared per second squared, or joule. What is the kinetic energy of a 10 kilogram trolley that is moving with a velocity of 0.2 meter per second? The kinetic energy of the trolley can be calculated using the formula half mv squared. On substituting all given values, kinetic energy of the trolley is 0.2 joule. So, 0.2 joule of energy was required to move the trolley of mass 10 kilograms with a velocity of 0.2 meter per second. What happens to the kinetic energy if velocity is doubled? When the velocity is doubled, the kinetic energy will be increased by 4 times. Observe the swing. When the swing is at the highest position, energy is stored as the gravitational potential energy. Once it starts swinging, the potential energy is transformed into kinetic energy. As the swing goes up on the other side, the potential energy increases. Gravitational potential energy is the energy stored in an object by virtue of its vertical position. Let's consider another example of gravitational potential energy. Consider a boy dropping a ball from a height. When the boy holds the ball at a height h, he spends energy in holding the ball against the gravitational pull. This energy is stored as gravitational potential energy. What is the relationship between gravitational potential energy, the height, and the mass of the ball? There is a direct relation between gravitational potential energy and the mass of an object. More massive objects have greater gravitational potential energy. There is also a direct relation between gravitational potential energy and the height of an object. The higher the ball is elevated, the greater the gravitational potential energy gained. If the mass of the ball is 0.5 kilograms, and if it's lifted by a height h equals 1.0 meters, calculate the energy stored in the ball as the gravitational potential energy. The gravitational potential energy of the ball is the work done by the boy in holding the ball against gravity, which is calculated using the formula mgh. 14.7 joule of energy is required to lift the ball of mass 0.5 kilograms to a height of 1.0 meters. According to the conservation of energy, energy can be converted from one form to another, but it cannot be created or destroyed. To demonstrate the principle of conservation of energy, let's consider a roller coaster. Click on the Start button to begin the simulation. The total mechanical energy TME, kinetic energy plus potential energy, is always the same. The kinetic and potential energy of the system varies such that the total mechanical energy is always constant. At which point is the potential energy maximum? At which point is the kinetic energy maximum? Why is the height of successive loops in a roller coaster lower? The useful energy in lifting the roller coaster decreases with each loop because there is a loss of energy in the form of sound and heat. For the roller coaster to be able to continue its motion, the height of the loop is reduced. We can see an example of conservation of energy in the motion of a simple pendulum. Drag the pendulum bob to any position. Then, click on the play button to oscillate the pendulum. Observe the indicator for the kinetic and potential energy of the system. You will see that when the kinetic energy increases, the potential energy decreases, and thus the total energy of the pendulum remains constant. In the case of a simple pendulum, at the highest point of the swing, the potential energy of the bob is maximum and the kinetic energy is minimum or zero. As it comes down, its potential energy decreases and its kinetic energy increases. The reverse goes up. At the lowest point, the potential energy is minimum. It's maximum.
A ball of mass 0.25 kilograms falls from a height of 55 meters. Calculate the total energy at point A, point B, and point C. Complete the table. The potential energy at the top of the platform is 50 joules. Calculate the potential energy at each step.